So let's discuss a topic from quantum mechanics. So here we are going to discuss about electron in an electromagnetic field. So the equation for electron, which is supposed to be if the electron was in electromagnetic field, or else which is also could be said as Klein Gordon equation in electromagnetic field. So what is the Klein Gordon equation in electromagnetic field? So we are going to study about this topic. So electron in an electromagnetic field, or Klein Gordon equation in electromagnetic field. An electromagnetic field can be uniquely represented by a vector potential A and a scalar potential phi. So we can represent electromagnetic field uniquely. So how to represent electromagnetic field? It consists of electric field as well as magnetic field. So electric field could be represented with the help of this scalar potential. So it is a scalar form. So we have electric field E is equals to negative gradient of potential energy. This E is equals to negative gradient of potential energy, or V we can say. That is because this is a scalar quantity. By doing gradient, which is a vector quantity, we are converting this scalar into vector form, as E is a vector quantity, like that. And another one thing we are having is vector potential, because B is equals to curl A. So this one says about the magnetic field, this vector potential. This tells about the electric field, as electromagnetic field is a combination of these both. So hence we are using these two potentials to define them. The respective potentials we are going to use. So these potentials form a 4 vector. So the potentials which we are having here, they form a 4 vector whose components are A1, A2, A3, A4 is also I5. So that is A bar is a vector, so it has X component, Y component, Z component, AX, AY, AZ, A1, A2, A3, and A4 is nothing but I5. And finally phi also if we include. So you would get in total 4 vectors. So that is the thing. And transform like momentum energy 4 vector. So it would transform to the momentum energy 4 vector P nu having components. So which has the components P1, P2, P3, P4, where P4 is IE by C. So it has these many components just like here. So therefore the potentials A and phi should be included in Klein Gordon equation with momentum and energy. So we need to include these potentials in this equation. Why? Means it is an electromagnetic field. So that is the thing they are mentioning. So next, if electron is the charge on the if E is the charge on the particle, then in analogy with non-relativistic expression, P and E are replaced by, so P has to be replaced with this momentum P minus EA by C. If we need to, if we don't give up electromagnetic field, if we consider the effect of electromagnetic field also, then we need to take this, and E is the charge on the electron, and E this is momentum has to be represented. P has to be changed to this form, and E has to be changed to this form, E minus E5. So you can see here, so P has been changed to P minus EA by C, and E has been changed to E minus E5. So the relativistic expression between momentum and energy of a particle of charge E in electromagnetic field becomes. So we know the famous equation from the theory of relativity: E square is equal to P square C square, P square C square plus M square C power 4 plus M square C power 4. So in this equation we need to substitute these values. So in the place of E minus E5, so we have substituted here. And next in the place of p minus ea by c. So here in the place of p square c square we have mentioned it, and the m square c power 4 would remain the same. So that is the thing. So on solving this, so here we can take c as the LCM. So pc by c we would get pc minus ea by c square. C square would get cancelled, so this would remain, and m square c power 4 and e minus e5 as usual. So replacing operators. So in quantum mechanics we deal with operators, energy operator, momentum operator. So replacing operators E and P by, so energy operator is nothing but I h cut dou by dou t, and momentum operator is nothing but minus I h cut del. Respectively, we get Klein Gordon equation as. So now we would get the Klein Gordon equation as follows. So this is the Klein Gordon equation we used to get after the substitution. So here we can see it, the substitution. So see here, so this is the equation. So this is the main equation. So on both sides we need to take xi function, here xi function, here xi function, and e has to be replaced with I h cut dou by dou t, and p by this minus I h cut del. In this second equation, if we replace, we would have this equation. So this is the equation. So this is nothing but e square xi, just we have discussed here. So this part, e minus e5 part. So in the place of e, I h cut dou by dou t. This is in the place of p minus I h cut del minus ea whole square plus m square c power 4 into xi. So after replacing, we have got these terms, and next what we need to do is we need to elaborate, simplify each and every term. That is this square we need to elaborate now, simplify now. So first taking this one, this part, left hand side part. So here we can see I h cut dou by dou t e5 whole square xi. Now if we expand this square, that means if we consider this as a square could be written as a into a. So that one we need to do. But here a is of the form small a plus b. Small a plus b into a plus b. It is of that form. So first of all, as this is an operator form, order is very important. Whether it is AB or BA, that is very important here, order. So first of all, a into a square, that is I h cut dou by dou t whole square we would have. Next, a into b, ab. So this is just like ab. Next, b into a, ba. So this is like ba. And next, b into b, that is b square. B square is nothing but e5 minus e5. Minus e5 whole square is e square into 5 square. And next important thing is, here we can see first this a multiplied with so for example, here first dou by dou t has to be multiplied with this phi xi, this phi, and next xi. So that is the thing here, ab. Next, this term has to be multiplied with this, that is ba. So e5 into what is there in this term, dou by dou t, and I h cut is a constant. So that's why we are getting these two terms in this manner. So what is the difference we can observe here is, here phi is residing inside the differentiation, dou by dou t. Here phi is outside the differentiation. That is because of this product. So in quantum mechanics, AB is not equal to BA, because here we are taking the help of operators. So we cannot say AB is equals to BA. Hence we are not having in this formula a square plus 2AB plus B square. We are not using that normal formula. So this is in the form of in the place of a square, this is in the place of B square, but these are not 2AB. They are just AB and BA added together. So here minus sign is there, so that's why here we are having minus minus. So understanding the calculation is very important. So next what we are having is, so this minus h cut square dou square. Now next we are taking this xi into the inside of this brackets. Still we haven't taken this xi inside of the brackets, so if we take it inside, so this dou square by dou t square multiplied with xi, we would get this term minus h cut square dou square by dou t square. And next this next step is very important, could be confusing. So this xi multiplied with this inside, so already there is dou phi by dou t. Already we are having dou phi by dou t. Already we are having dou phi by dou t. Next we are multiplying with psi. So what would happen is we would have dou by dou t of phi into xi. Dou by dou t of phi into xi, which is of the UV form. So now we need to apply UV formula. So first of all, xi into dou phi by dou t. So here you can see xi into dou phi by dou t. Next xi, phi into dou xi by dou t. So this is phi and this is xi. Next we are having phi into dou xi by dou t. Here you can see phi into dou xi by dou t. But here we are having 2. Here there is only 1. So y means this is one form. Next here if we multiply with xi inside, what we would have? We are having only simply we are just having here dou by dou t. So dou by dou t multiplied with xi is nothing but dou xi by dou t. We would have another dou xi by dou t term. So already here we are getting one dou xi by dou t because of the so already because of this here in from this term, because of the UV formula, we are having already one dou xi by dou t term. Next here also we would have another dou xi by dou t term, and here also minus, here also minus. So both added together minus 2i h cut phi dou xi by dou t, we would have this term, and this is e square phi square. So like that we are having. So that is the so each and every calculation step is very important here. And next thing is, now coming to next step. So here now what we have done is we have expanded this term, this left hand side term, that is the result of this. Now we need to expand this one. So here is the expansion. So xi taken inside, so here this is regarding this expansion. Here also same thing, we need to use a plus b into a plus b formula, a into a, b into b, a b, b a, same. So a into a minus I whole square is nothing but minus into minus, so there might be confusion in doing minus I whole square. So actually if we take minus I, so whole square if we do, so minus I whole square if we do, it could be minus 1 whole square into I square. So final what we would have is minus 1 whole square is 1 plus 1, I square is minus 1. So if we do squaring of this term, we would have finally minus. So that is the minus here. Especially while doing minus I square, confusion arises. And next I square and h cut square, c square, del square, so they are all the same. And next this term into AB, so this term into this term we would get, so that is nothing but here it is mentioned. So I h cut the divergence of a xi, a, and next a into divergence of xi. So like that, there's like we need to do here dot product. So here as this is a vector form, here it is of a normal scalar type form, but here it is a vector type form. EA is a vector, this EA is vector, IH plus C del is a vector. So we know that A dot A is equals to A square. So that is the thing we have to do. So here it is A square, so that is nothing but A dot A, hence we are having dot here, dot product, we can observe dot product here. So this is nothing but a dot a, small a dot a, small b dot b, a dot b, small a dot b dot, sorry, small a dot b, this is small b dot a. So that is the thing. By doing dot product, we would get these things. Hence we are having del dot a xi here by taking xi inside, and after doing dot product, so after doing dot product we would take xi. Only after doing product we need to take xi, just we have taken here. So here also b dot a, that is ea dot xi, ea dot del xi. So has we have included del into xi like that, just like gradient of xi like that. So that is the thing. So next ea dot ea minus ea dot minus ea is nothing but plus e square a dot a square, and after taking xi we would have this term. So now again we need to take xi out, taken common out, we would get arrive at this step. Next, substituting these values in 31, the Klein Gordon equation for a particle of charge in electromagnetic field takes form. So this is actually this is equation 3. So substituting these values, so all these elaborated terms, expanded terms are to be substituted in this equation, this third equation. So that is the meaning of this. The Klein Gordon equation for a particle of charge in electromagnetic field takes the form. So after substitution, what we will get is this. So this is this expansion which we have now only found out. So we would have had this term. And next important thing is here, this is the formula which we have used here in the calculation of this. That also we can say. So like that also we can say. It is nothing but divergence dot a xi, xi divergence of a plus a dot gradient xi. So that is the thing we have got here, a dot gradient xi, divergence a. So the like that, xi into divergence a, that form also we can, in that manner also we can take. But basically it is just a dot product here which we have involved a dot a. And next thing is to find connection between equation 4 and similar non-relativistic equation. Let us make the following substitution, making mc square as the rest energy. So we need to find connection between equation 4 and some non-relativistic equation. So because of non-relativistic effects may come, the following substitution with taking, we need to take mc square as the rest energy, and we need to substitute this. So xi of r comma t has to be replaced with xi dash of r comma t e power minus imc square t by h cut. So this is the value we need to find out, minus mc square t by h cut. It is just like mc square by h mu, like that. Mu is nothing but 1 by t, so that form. So dimensional analysis based on. So we need to replace xi with this term. Next, by keeping in mind relativistic effects, because here electron is in motion. It may move with speed nearly equal to the speed of light. So in that case, it's relativistic effects we may observe, time dilation, mass increase in mass, like that, mass of the change in the mass of the electron. So for that we need to replace xi of r comma t with this term, xi dash of r comma t e over minus imc square t by h square. So what we would get is, so first of all we need to differentiate xi with respect to t, dou xi by dou t, because here we would get dou by dou t. When we take this xi inside, we would have dou xi by dou t. So because of that, now we need to make calculations to simplify this. Again we are having dou square by dou t square, which is nothing but dou square xi by dou t square. So this many calculations are there. So now let us see that those calculations. So first of all, dou xi by dou t. So differentiating on both sides of this equation, what we will get is, so this is a function of time and this is also a function of time. So what we need to use is differentiation of UV formula, and that is VDU plus UDV. So first of all, so here U is, this is U, xi dash is U, and e power minus n square c square t by h cut is V. This is U and this is V. So based on this, if we do calculations, so first of all, keeping V aside, that is e power minus im c square t by h cut. If we differentiate dou xi dash by dou t, V du we are having. Next, in the next case, what we need to do is, VDU we have found out. Now UDV. Now we need to keep this xi dash term aside, and we need to differentiate this V term. So if we differentiate, what we will get is, we know that differentiation of e power ax is nothing but a into e power ax. So here also xi dash is remaining aside. So differentiation of e power this term is e power that term multiply with a. Here a in the place of a, what we are having is minus imc square by h cut. So this is the term we are having, ax. In the place of x we are having t. So minus imc square by h cut. So that is the thing here. And next we need to find out dou square xi by dou t square. So here is that, so we have already found dou xi by dou t. So this is dou xi by dou t. Next, dou square xi by dou t square. So for this, what we need to do is differentiating on both sides again with respect to t. So that is the thing we have done here. So here again we need to use UV formula. So this entire thing is taken as U and this entire thing is taken as V. So if we do so, what we will get is, here you can see dou by dou t, or else we can just split it up. So that also we can do. So here it is of the form a minus b into c. So we would have ac minus bc. So that is the thing we have done. So after multiplication we would have this, and here also after multiplication we would have this xi dash e power minus imc square t by h cut, and this imc square by h cut is a constant, so it has been taken out. So minus imc square by h cut. Now we need to do this again. We can use UV form. So this is U and this is V, and here also this is U and this is V. So anything, as we are using just a differentiation, not integration of UV dx, we are just using differentiation. So based on that formula, what we would have is, so first of all here, so first we are keeping this one aside, so here, and differentiating this one. So dou square xi dash by dou t square. And next what we are doing is, we are keeping this one aside and we are differentiating this one, that is a e power ax. That is, in the place of a we are having minus imc square by h cut. T is nothing, e power ax. So in the place of a minus imc square by h cut, so into dou xi dash by dou t. Here also, next here from this also the same thing. This one we are keeping aside, dou xi dash by dou t, and next this one we would keep aside, we will differentiate. So already here one imc square by h cut is there. Again in this on differentiating this one, we would get another imc square minus imc square by h cut. So that is the thing here mentioned, it is mentioned here. So finally what we would get is, everywhere e power minus imc square t by h cut is common, so it has been taken out common. So here, from here we would get dou square xi dash by dou t square. So that is the thing here. And next from here, minus imc square by h cut dou xi dash by dou t. Here also dou xi dash by dou t minus imc square by h cut. So both put together we would have minus 2. Minus 1 is nothing but minus 2. And finally here what we will get is, here we need to keep an eye. So here minus, already one minus is there. So this minus into this minus plus. And again what we are having is I into I, that is nothing but minus. So hence we are having finally minus. And next m into m square c square into c square c power 4 h cut square. So finally we would have this in the place of dou square xi by dou t square, we would have this. So for now we have found dou xi by dou t and dou square xi by dou t square. Now we need to substitute them in here. Here dou xi by dou t, here dou square xi by dou t square. Now we would do substitution. So substituting these values in 4 we would get. So after the substitution we would get these terms. After the substitution and the simplification we would get this. Now what we have to do is cancelling out the common factor e power imc square. So here if we see this could be cancelled on the left hand side and right hand side. Next, and m square c power 4 into z dash on both sides. Here m square c power 4 is there and here also m square c power 4 z dash is there. So after this multiplication, this is multiplying, here this is multiplying, here also it is multiplying, so that they both get cancelled, and here it is adding, here it is adding, so they both get cancelled. So what we would let, and next after these cancellations what we have to do is dividing throughout by 2mc square. Entire thing has to be divided with 2mc square, because here everywhere we can see minus 2mc square, mc square, so like that is there. So now we need to divide entire thing with 2mc square. So if we do so, what we will get is, so here you can see, so here there is no 2mc square term here, so minus h cut square by 2mc square, minus h cut square by 2mc square. Next, here 2mc square term is there, so after dividing they both would get cancelled. What would remain is only I h cut dou z dash by dou t, so that I h cut dou z dash by dou t. And next also the same, so 2mc square, so would get cancelled and c square would get cancelled, and what would remain is here 2 here 1, so half mc square, sorry this is z dash, here we can see 2mc square, actually 2mc square into z dash, sorry actually this term was eliminated, so here it is eliminated, so this term won't count. Next again mc square, if we do here minus I h cut by mc square, we would have minus I h cut by mc square. So like that, in a similar fashion, if we keep on going this, so if we keep on in the same manner, if we do this 2mc square for each and every term of this equation, finally what we would get is this equation. So finally we would get this is the final equation after dividing with 2mc square. In the similar fashion, if we see for this term, all the terms, if you look upon, you can solve it by yourself. So we would get finally this equation. Now keeping in mind that rest energy mc square is much more greater than non-relativistic energy E. So rest energy of the electron is much more greater than non-relativistic energy. That is, mc square is much more greater than E5 and mc square is much more greater than E. And we may neglect terms of the order 1 by mc square as compared to E dash and E5 and rearranging. So wherever the terms are having 1 by mc square, we could neglect them as mc square is much more greater. So here 5 e by mc square is there, as mc square is much more greater than that is mc square much more greater. So actually here mc square is much more greater than E5 or E. So then what we would have is uh, if we do E phi by mc square, dividing with mc square on both sides, we would have 1 is much more greater than that ratio, that is E phi by mc square. That means this ratio would be much more less than 1. That means it is nearly equal to 0. So that is the thing they are mentioning here. So here this term would become 0. Here also 1 by 2 mc square is there. So like that we could neglect these terms. These so here mc square, this mc square, and here also mc square, these terms. So here also 2mc square. So these terms could be neglected. So here you can see from the left hand side only we have taken this term, that is I has got dou z dash by dou t. Remaining and all are having 2mc square, mc square, e phi by, especially numerator also we need to observe phi is there. So energy ratios, that is nothing but ratio of energies, and E is nothing but h nu, like that if you consider. So this term would remain, and from the right hand side all these terms would remain. Here we are not having E phi, so this term has remained. E phi by mc square ratio terms has to be eliminated, and energy terms has to be eliminated, that is hsi, h nu terms. So after eliminating all those, what would remain is, this is the equation which would remain after neglecting all the terms. So this is simply non-relativistic Schrodinger equation for a particle of charge in electromagnetic field. So this is the non-relativistic Schrodinger equation. You can see for charge in electromagnetic field, the Klein Gordon equation in electromagnetic field reduces to correct non-relativistic limit with appropriate approximation. So finally it is getting reduced to non-relativistic Schrodinger equation. Finally, however, we are getting, that is hsi is equals to Esi. So this is hsi, I h got dou xi by dou t. Esi, E is nothing but total energy. So here you can see kinetic energies and potential energies. Here also energies because of the magnetic field and electromagnetic field. So all the energies added up together into psi dash, which is just simply hsi is equals to Esi. So finally we are getting non-relativistic Schrodinger equation after solving this electron in an electromagnetic field equation. So this is the topic. So thank you.